Good morning, everyone. It's good to see you all. Happy Friday. I'm pleasantly surprised to see so many of you. It's day 5 and bright and early. It's nice to see you all. So how many of you can I have a show of hands of whether you have struggled to establish data lineage from source to target to tell the full story? Wow. Okay, I have some on the stage too. Yeah, this is a common struggle that we've heard about, and today in this session, we are going to talk about what is data lineage, just to make sure all of us are on the same page, and also about OpenLineage, a standard that's pretty commonly adapted for standardizing lineage, and then what at AWS, what we have done to introduce Lineage as part of DataZone and also part of the latest launch that you heard this week on the SageMaker Unified Studio. So I'm Priya Tirutani. I'm a product manager with Amazon DataZone. And with me, we have Harold, who's with the OpenLineage community. He's one of the members of the technical steering committee. We have Rob, who's from San Diego Gas and Electric. He's a group product manager. And then we have Leo, my partner in crime, in making sure DataZone works, tests, and he'll be showing you a demo of how Lineage looks like in the product. With this, okay, let's see what we are going to talk about.
Go.
All right. Just to make sure you're all awake and listening to us, we've jumbled the agenda a little bit. So first, we're going to talk about what is Lineage, and Harold is going to introduce a little bit about OpenLineage and why they created this framework. And then I'll dive into what is available in DataZone and what we have built. Leo will jump into a demo to show you how it works in the product. And then we'll have a customer story from Rob on how they've actually implemented DataZone and using Lineage for their end users. With this, I'll hand it off to Rob.
Cool. Thank you, Priya. Thanks, everyone, for coming. So my name is Harel, and I am a senior engineering manager at Datadog, but I'm also a committer on OpenLineage as part of the technical steering committee of the project, and I'm here to talk about OpenLineage. So assuming most of you know what data lineage is, let's actually talk about why we need data lineage. So in organizations, we know we have multiple teams, we have multiple data sets, we have multiple technologies, we have multiple frameworks and jobs, and things are running in parallel across multiple teams, and that makes it really, really hard to work together. So even on a small team, sometimes there are things that get missed in communication, in documentation, and building a healthy data ecosystem is really, really a challenging job, especially with the amount of various technologies and frameworks that teams use. And so that's just one aspect of kind of why we need Lineage to be able to connect the dots and capture which job is creating which data set and which job is consuming from what data set. Why do we even need that? So our business wants to develop new opportunities. It wants to optimize. And to do that, it needs good data. But to have good data, you need that data to be available, you need it to be fresh, and you need it to be of high quality. Now, once you have those things, and you have data lineage also as part of that picture, the possibilities of what you can do are really, really amazing. Because you can think about a data outage is now going on, and you can pinpoint exactly, go all the way upstream and pinpoint exactly where some job is being failing or someone has changed the schema on a specific thing, and now I can find the issue and remediate the root cause quite quickly. We can think about use cases for compliance, right? Think about the governance and provenance of data, anomaly detection. Really, there are so many different possibilities. And actually, doing lineage and capturing lineage across your entire ecosystem is really, really, really hard. It is never fully automated. It is never happening in real time. It's never giving you a 360 view. It's never easy. It's actually a lot of patchwork and trying to figure out many things. And so because of all these reasons and all this context, we came up with the idea of OpenLineage as a standard specification and protocol for capturing data lineage. So let's think about what is the right time to actually collect lineage. So we can potentially look at, I don't know, SQL queries, try to infer it from that, parse it there. We could try to look at source code. Or we can look at the data as it is being generated and as the jobs are running. So if we take the analogy of us trying to take a picture, we can look at that picture and see, OK, the sun is about here. I can see some rocks over there. So I'm going to guess this is like close to sunset, and I can guess maybe where I am. Or I can just look at the metadata from the camera, right? Isn't that easier? And so with OpenLineage, the way we started was the idea is to find the open standard for the collection of metadata from data pipelines as they are running. There's a caveat here because this is actually evolving and changing over time. But largely, this is how we started. Let's look at where OpenLineage fits into a data ecosystem or a data pipeline, right? So we have multiple types of producers of data. I'm sure these are names that most of you know about, like Spark, Airflow, dbt, Flink, Great Expectations, different types of either data processing frameworks or data quality frameworks. They can all produce data and emit it in OpenLineage format. Then we have different consumers. One of the consumers announced this week their compatibility with OpenLineage, which is AWS DataZone that you will hear about from Priya. And basically, those consumers can standardize on the spec. Let's talk about why that is actually important. So before we introduced OpenLineage, basically, there was a lot of duplication of effort. Every single framework needed to find a way to talk to every single consumer of that data. Right? Every single consumer needed to find a way to integrate with all the different frameworks. That's just a lot of unnecessary work, really, because no one wants to write more integration code, right? We want to focus on what's important for our business and not rewrite the thing every time. So with OpenLineage, basically all those producers just need to figure out one way of presenting that data, and all the consumers have a standard way of doing that. There are some details there. But before I go into some details, I want to say that we could not be here where we are after years of this project without all the major contributors from all these companies and organizations and frameworks that have helped us get to where we are. So I want to take a moment to acknowledge and thank all those different contributors. Where we are today is you can see the producers of OpenLineage data as well as the consumers of OpenLineage data. That list is growing. I'm sure that the slide might be outdated by this point. So it's very exciting, and I'm very happy to see how far we've come along this way. If you want to check it out, go to the OpenLineage website, and you can see exactly what is supported. So diving back into the details of OpenLineage. The way we reference the stack, the way we kind of imagine someone using OpenLineage, is we have, at the bottom, you can see a bunch of different frameworks producing lineage information. So an Airflow job is running, that job is producing lineage information, and that data is then being sent to some sort of metadata collection API. We started off with a reference implementation of Marquez, which is a metadata repository that can not only capture data lineage, but also kind of capture versions of data jobs and versions of data sets as they evolve over time. So this is something that's very useful if you want to test out and try OpenLineage. You can use Marquez. It's a reference stack, and that allows you to kind of play and visualize a lot of that lineage information. The way that it generally works is all those different types of jobs, as they run, they push out events to Marquez or another OpenLineage compatible backend, like what you'll hear from Priya about today. And then on top of that, you can query the data, you can build user interfaces, you can solve business problems with data. I want to spend a minute to talk about the data model for OpenLineage. So basically, the data model for OpenLineage, when we talk about data jobs and runs, is we have the concept of a job, right? Some sort of data process that runs. That job has some source code to it, it runs, and then every time it runs, we capture, hey, there's a new instance of this, it started running. There's a new instance of this, it started running. Data sets can be inputs to those specific runs, and they can also be outputs from those specific runs. As the job runs, there are transition events, right? So you can imagine a job is starting, it's running. If we're talking about batch jobs, then they will get to complete at some point. Sometimes streaming jobs just kind of stay in a running state and can emit events as they happen. And also sometimes jobs can fail or get aborted. So this is a bit of the life cycle of OpenLineage events. One last thing I want to say about the spec and the standard before I hand it off to Priya to talk about what they've done with it at DataZone is that kind of at the core of it, we've built OpenLineage in a way that is very extensible. So we have a concept of facets that anyone can go in and extend either the job or the data set or any other type of metadata and add in more of their own context. There's a facet registry that folks can go into the open source repo and add in their own things, or they can keep it private. So that really kind of keeps a good balance of what is the standard, what is the spec, what we expect everyone to be doing, and where you can customize and build your own logic on top of that. So with that, I'll hand it out to Priya to talk about DataZone.
Thanks, Harold. Thanks to you and the OpenLineage community for giving us a framework, because I think one of the biggest impediments that we've had is the interoperability between the different sources and the tools. So you're able to understand the data movement, not only from where it's coming from or what happens to it, but also capture when some executions are going on. So let's quickly see what we did in DataZone. So I think many of you have contributed to this in a way, because we got a resounding feedback from customers saying, we need data lineage support for our analytics tools. And when we started talking to customers and we wanted to understand what is it exactly that they're looking for, one thing that came loud and clear was they wanted the end users to be more productive, to make better data decisions, and also to comply with regulations. So having these conversations, we wanted to root our use cases in 4 themes and make sure that we're able to address those use cases end to end. So the first theme that was very clear was trust, where they wanted the data users to know where the data is coming from, so they know that they're using the right data for the analysis. The second theme is impact analysis. They wanted to make sure that any change that they're making is not going to break something downstream. So they wanted to be more proactive to avoid those incidences. Third is troubleshooting, and in data world, there's always data errors. And when an error happens, they wanted to catch that in a timely manner, root cause it quickly, and also fix it quickly. And last is governance. Of course, you want to know where the data is coming from, where it's getting used, and why it's getting used, and who's using it. So you wanted to see the end-to-end picture, and that's exactly what we tried to make available in Amazon DataZone. So what we've done is we went the OpenLineage way. So whatever we built is OpenLineage compatible, which means we are able to consume, like Harold said, many of the plugins that's already available in the market. So you can actually start using the open source plugins that are available with DataZone, so we start understanding those events and capture it and visualize it for you. Second, we are trying to automate with our tools, and of course, we'll start automating with the third-party tools as well. At GA, which we launched this week, we released the automation from Glue and Redshift. And you doing that, as you bring data from the Glue catalog or Redshift, we are able to capture lineage from the source, and also when you execute them as ETL jobs in Glue or in the notebooks. And of course, it's not going to end with that. We just scratched the surface, and we're going to build a lot more integrations with various other tools as well. Then we have this rich UI experience, which is part of DataZone and also part of the SageMaker Unified Studio that we just launched. The goal here is we want all of your data users to go to this one place where they can go find the data, understand it, and while they're learning about the data, we want them to understand data quality as well as lineage, so they can understand, okay, is this a data that I was using earlier? I know it came from an Oracle database, it got moved to cloud, and is this the same data that I'm getting access to now when I want to do my analysis? Because we all know having the right data is important for your analysis or model building or for any of your generative AI experiences. And last, you'll have one thing that we wanted to make sure, given that we had these 4 themes, is to have lineage support for columns, but also support versions. Because when you want to troubleshoot, you really want to narrow down where the problem happened. You want to go see where the query changed, or where the table changed, or a column got renamed. You want to really go pinpoint the problem area to know exactly what changed at what time. So we added support for versioning, where you can toggle between the different versions of a given node, and you can compare and contrast to quickly catch the difference that's happened from the previous workflow. All right, let's take a use case quickly just to see how what we build is tying up into those 4 themes that we discussed earlier. So we have Marina, who's a marketing analyst, and she wants to do some marketing analysis, and all she was looking for is the right data for her analysis. Second, we have Julia, who's a data engineer, and there are 2 things to her job. One is she needs to make sure any change that she does is not going to break something downstream. And of course, she gets asked all the time saying, hey, my dashboard was working good yesterday, what happened? And where things broke, why is it incorrect today? So she needs to go into this troubleshooting mode sometimes too. And of course, we have Susan, who's an administrator, and also she wears a steward hat, where she works with auditors to answer some of the questions that auditors want to know about how data has moved, what has changed, is it coming from the right place, is the data getting visible to the wrong hands. So she has to answer a lot of questions, and she wants to use some tool that helps her get those answers quickly rather than meeting with individual teams, which takes more time. All right, let's take one use case at a time. So first comes Marina, who wants to know the origin of data. So she goes into DataZone, and when she goes into a particular asset in the data marketplace, she searches for it. She's able to navigate for the different descriptions of the asset. We have the metadata, business metadata descriptions. We have the technical metadata. We have data quality. And one tab that you see here is the lineage. And what you see, when she goes in there, she's able to go upstream, navigate, and she's able to see where the data is exactly coming from. The second is Julie. Here she wants to quickly know who's using her data. To know, once she's making a change, she wants to know whom she needs to notify and take actions proactively. In DataZone, we give this handshake between the producer and the consumer, and so Julia is able to see who are actually using that data. And since she's able to visibly see that who's using her data, she can quickly say, okay, I'm going to change this table, or I'm going to change this column, where she goes and notifies those teams in a timely manner, so any downstream impact is avoided. Third is troubleshooting. So given that Julia is already aware of this asset and she knows who's using it, when any data issue occurs, she quickly goes to that particular asset, and she's able to go to the version of that particular node, and she's able to toggle to figure out, has anything changed in the data set, has anything changed in the job, and she's able to quickly narrow down the root cause to fix the problem. And of course, we have Susan, where she goes to this graphical interface, and as she gets questions from the auditors, she's able to look at a particular asset, navigate the graph, and now she's able to see the column lineage, so she can quickly track which column has changed and how it's aggregated, how it's getting consumed. And eventually, we will be adding sensitivity information in the columns, so she can also find out if that particular column that's sensitive, it's going into the wrong hands, or is it still being contained in the right manner. So now that we saw all these use cases, let's see this in action. And now I'm going to invite Leo to come and show us how it actually works.
Hello, everyone. Once again, thank you for coming the last day of the event. So we really appreciate that. So this is the architecture of our first demo today. Okay, it's a simple workflow, but it's simple, but at the same time it's powerful because it's very common. Okay, we are going to extract data from an Amazon Aurora database based on MySQL using a glue job. We are going to send that data to a S3 bucket. Okay, we are going to catalog that data using our technical catalog, in this case the glue catalog. And then we're going to use a second glue job that is going to perform some aggregations on top of that data. And the result is going to be, again, cataloged in the glue catalog. And then we are going to publish that new data asset in our business catalog, in this case, Amazon DataZone. Okay? Let me show you how that looks like. Okay, so this is the Amazon DataZone homepage. Okay, we are going to work on top of the total quality per buyer data set. So here you can see the business metadata tab, in which you can see a summary and a use case description that was generated using GenAI, by the way. Okay. Also, you are going to have glossary terms. You're going to have metadata forms, everything that you need in order to document your data asset. Here, you can see the data quality tab, in which you can see the data quality scores. Okay. And now, let's go to the Lineage one, the most important of today's session. So here, you can see the diagram that is generated by DataZone. Okay. Let's start in this case from right to left for now. Here you can see the asset, okay, that was published, okay, and you can see in DataZone, of course, and you are going to see the different subscribers to that asset. So in this case, because it's a simple example, you have just one. But if you have, I don't know, 20, 40 subscribers to that data asset, you are going to be able, thanks to this diagram, to identify who is subscribed to your data asset in a visual way. Okay? So you have here also the data set that was published, okay, as part of your DataZone data catalog. Okay? If you see, the name is the same as the one that we have on the top. And here you have the asset that is part of your Amazon DataZone inventory. So if you see, we have three, let's call it red icons. That means that all those assets are in the scope inside of DataZone. Okay? So here you can see when we click a node, you can see different information about the asset. You can see the schema information. You can see the Lineage general info, and also you can see the history of that node. Okay, if something changed and you have a new version of the Lineage diagram, you are going to see the different version of it. Okay, perfect. And you can see the previous version if you want to. In this case, this asset is a glue table, as I showed you before as part of the diagram. Okay. Again, red icon means that we are working in the DataZone side. If you see that blue icon there and you see the name dataset, we are talking about the source. Okay. In this case, if I click there, you are going to see that the source is a S3 bucket, as I mentioned before. You can see here in the information tab some technical details like the location, the schema, okay, of that data asset, and also the history. Okay, perfect. Let's move a little left in this case, and here you can see our first job. Okay, this is a glue job, but you're going to have the same information. For example, if you enable Lineage on EMR. To give you an example, okay? Because both of them support Spark. So in this case, we have information about the Spark job itself, or the glue job itself. As you can see here, you can see that was Spark. You can see the execution time, and so on. And actually here, you can get more information about the job run ID. Everything that you need to understand the job that was run in order to generate that data set. So if I want to extend further to the left, I can do it clicking that arrow there, okay? And here you can see the two sources that we use in order, to generate the data that was processed by that job, okay? So as you can see here, we have two glue tables, as I show you as part of the diagram, okay? In this case, the first one was users, and the second one was sales, okay? So glue tables, information that you already saw in one of the previous nodes. You can see here the location of the data. Okay, that's very important to keep a track of everything that happened with this pipeline. Here we have two jobs. Let's call it two ingestion jobs, where we use these jobs to extract data from the Aurora database. In this case, the MySQL database. Okay, so again. Spark jobs, in this case glue jobs, you can see the job run information, parameters that we use in order to run the job, and so on. Okay? Perfect. The same with the second job that we use for the sales table. Okay? Here, something that I want you to pay attention is that this one is different from the rest. Because if you see here, the source is MySQL. Okay? So in this case, Aurora database. So it could be MySQL, it could be Postgres as well. But if you see, and I have been working at AWS for 5 years, and being able to see a lineage diagram of based on a group of glue jobs is something that for me is still amazing. So yeah, this is great to see that we can track the origin of the data from the very beginning, in this case from the relational database to the business catalog. Okay? So as I mentioned before, you can see the details about the source. Okay? And now, let's see how the lineage looks like, but from the column point of view, at the column level. Okay? So here, if I click that blue arrow there, okay, you can notice that in the first column, the first table, we have 16 or 18 columns. In the second one, we have 10. Okay? And now you can see the diagram at the column level. So I'm organizing here the different nodes for you to visualize it in an easier way. Okay, so if you see, we have the ingestion jobs, but the thing here is that all the columns are exactly the same because the only thing that we did was moving that data from the relational database to our S3 bucket. Okay, when everything becomes interesting is when we join those two tables, as you can see there in the job that is in the middle. Okay, and DataZone shows you the columns that we use for that join. Okay, even though we have in total like 26 columns, now you can see that from those 26 we use 5. Okay, as part of our aggregation job. Okay, and then the 5 columns stay the same because that is the publication workflow inside of DataZone. Okay, so but as you can see the full cycle. Okay, of the modification of the transition of each column until they got as part of the final result. Okay, perfect. So I'm going to switch here for a second. We have a second demo. In this case, the integration, the sources that we're going to use and the processes that we're going to, or the ETL jobs that we're going to use are different. In this case, the source is going to be a Redshift server, a Redshift cluster, and the ETL jobs are going to be using dbt, okay? 3-party vendor, no AWS service, but we are, thanks to the OpenLineage APIs, we are able to harvest the lineage metadata from dbt, okay? And then we are going to dump that data in another Redshift cluster, okay? And we are going to visualize the lineage diagram using DataZone, okay? Let's go with the second demo. Okay, in this case, we are going to use the sales by date table. Okay. Same tabs as you saw before. Let's focus again on data lineage. In this case, the diagram is way more simpler than the one before. Remember, red icons is everything that happens in the context inside of DataZone. Okay, so here you can see the table sales by date that was published, and the assets sales by date that we had as part of our inventory inside of DataZone. Okay, same exercise as before. If we click one of our nodes, you're going to see a lot of information. Okay. In this case, another difference that you can notice is that this node is a Redshift table. Okay, you can see the assets, the schemas as we saw before, and here is when we have our first. Here you can see the actual data set that was stored on Redshift, and here is where you're going to notice the first huge difference. That is not Glue, is not a Spark, is dbt. Okay, so this node was created on top of a dbt job. Again, same behavior as before. You can see here all the information related to that job, the execution time, some parameters related to it, and so on. Okay. Perfect. Okay, it's moving now. Okay, so let's expand the diagram to get more details. Okay, so here you can, let's turn everything at once. So you can see the sources that we use for this job. In this case, a couple of Redshift tables, as I mentioned before. Okay, as you can see here in the description of the node. Then we have the DBT job that we use for to extract that data from the source Redshift cluster to the destination. Okay, you can see all the metadata here, and if you go to the bottom, you can see that it says DBT. Okay, perfect. We have the data set that we generate. Again, it's not S3. In this case, is a Redshift cluster, Redshift table. You can see all the details about the table there. Okay? Perfect. So if we move on, a second. Another thing that you can notice here is we have the complete status. So if by any chance the job failed, you're going to be able to see it as well. Okay, that is important to notice. So we have here the data set that we generate, in this case in the destination cluster, again a Redshift cluster. And then we have the asset that we created in DataZone. Okay, in this case we can see the columns, okay, the lineage diagram at the column level. You can see also information about the schema, okay, that we generate based on as a result of the ETL jobs, okay, or the aggregation jobs. And again, you are going to be able to see the different version of the diagram. If you execute this, I don't know, like once per day and something changed, okay, and you want to go back, I don't know, I want to see what happened 3-4 days ago, you are going to be able also to do it, okay? So perfect. I hope that you like it. I hope that you understand how this works. As you see, well integrated with Amazon DataZone and very simple to use. Thank you.
Thanks, Leo. Hey, everybody. Super excited to be here today to share a little bit about our data governance journey at San Diego Gas and Electric. First of all, data governance is hard, but luckily, thanks in part to generative AI, it's probably the best time in history to start tackling data governance. So a little bit about San Diego Gas and Electric. At SDG&E, we provide safe, clean, and reliable energy to 3.7 million customers in San Diego and southern Orange counties. That's across 4,100 square miles of service territory. We have 4,000 plus employees with varying skills ranging from engineers to field personnel to meteorologists to IT professionals. We've been in business for over 140 years, and that certainly has some interesting challenges as far as data governance goes. So a little bit about our journey at SDG&E as far as data governance goes. We started about 4 years ago. There were things that we started with, including establishing roles and responsibilities, taxonomy, processes, cataloging, and identifying critical data elements. Eventually, we reached a point to where we needed to refocus our strategy, right? So our new strategy is really focused on improving upon those processes with the focus on people, as well as standing up scalable data platforms in AWS. So the 3 pillars of our new strategy are the data mesh architecture on AWS, the hub and spoke operating model, and creating reusable components that we can use to accelerate delivery and business value. So, with over 600 internal systems, we had data that was moving all over the place. We had data sprawl, We have our legacy platforms that had complex nested views that were built very purpose-specific, but they often crossed across domains. This was not sustainable, obviously, and we needed a new way to manage, govern, and share our data. This is where the data mesh comes into play. Data mesh is really centered around the concept of data producers and data consumers. Data producers are vertical IT teams that work very closely with the business to incorporate that institutional knowledge into robust, trusted data products. Those data products are then shared through our data mesh. Consumption happens from the data mesh where folks can develop their reports, their machine learning models, in the case of some of our business units, including wildfire mitigation, and even derived data products on top of those. With our new paradigm, we've established a new motto, which is really integrate once, consume indefinitely. This ensures that we're limiting the amount of duplication that happens for data, and we're optimizing each dollar that is spent on data. The data mesh enables us to build data products, which is essential to our success. A little bit about our solution architecture on AWS. So the data producer teams are utilizing native AWS services. Our centralized portion here in the middle is built on DataZone, which offers a catalog, glossary, access controls using lake formation, as well as Lineage. Our consumers consume those data into usable, shippable products so that we can get into data-driven decision-making. Okay. How we're organized. So we started off organized as a central analytics team with a centralized analytics platform. Again, with over 600 internal systems, that was not tenable. As an example, in my prior role, I was the manager over the asset management department's analytics and data team. So we were very dependent on that centralized analytics team to help us get our data into AWS. We soon realized that we needed to break that dependency and get those skills in our own teams. So what we did was reconfigure our teams to bring in data engineers, cloud engineers, and data scientists so that we could build out our workflows from end to end. This was a good example to go through, right? But it ended in an acceleration of delivery of value to our engineering and operations team. So building upon that success, we've established this hub and spoke operating model, with the hub being my team at the middle, where we provide the platforms, the governance, and a lot of the knowledge sharing that we can help federate on to the teams there. So the spokes are comprised of those agile product teams that work very closely with the business to make sure that we have business knowledge into the data products. The blue area in the middle is really the connective tissue that consists of our cloud office, our infrastructure teams, and cybersecurity. So with this new model, we're able to increase our capacity and increase agility in order to deliver value a lot quicker. This is something that's super exciting to share with you all. We envision DataZone to be an end-to-end solution for all of our data, not just data that resides in AWS. At SDG&E and Sempra as a whole, we're always going to have data that resides on our on-premise systems, right, in our data centers. So it's critical that we come up with a solution to catalog, do data quality upon, and produce Lineage for our on-prem data. Lineage has a variety of different uses at our company. One is around compliance. We have a bunch of different regulatory reporting requirements. We have certain laws that we have to follow, and that involves understanding a data's journey from source to target and any transformation along the way. With that in mind, my team developed a solution for our on-prem data lineage. So I'm going to dive in here to the architecture. First, utilizing a glue job, We query the metadata of our on-prem system. We land that in an S3 bucket. We then use a Lambda function to call Claude 3.5 Sonnet to translate that XML query execution plan into OpenLineage format at the column level. We then use DataZone's native APIs to post those events and expose those to our consumers so that they can see data for a variety of different reasons. Again, compliance, building out data products, and establishing a quantifiable trust in our data, which is super important to our success. And this is how we measure success at SDG&E. It's not only the typical things that you think about with data governance, including quality, observability, discovery. We care about our organizational adoption, our standards and guidelines, and knowledge sharing. Knowledge sharing is very critical for us because it allows our federated teams to, first of all, know what's going on. Second of all, so that we're doing things consistently, so that we're speeding up our delivery and ensuring that business value. With all those factors combined, we ensure that we're getting our bang for our buck and we're optimizing our money, right? And with that, I'm going to hand it back to Priya on an interesting new branding of DataZone.
Thanks, Rob. So how many of you here have used or aware of DataZone? Okay, quite a few. So we are excited to introduce Lineage because DataZone as a product, it helps you build that marketplace between the producers and the consumers. So producers are the people who are who are the owners of the data and who wants to share the data across the organization. And consumers are the ones trying to build analysis and models and want to find the right data. And we all know that data is siloed sometimes and you don't even know that the data exists. So the consumers are able to go to DataZone, find the data and able to understand it. And now with Lineage, and given that we are rooting ourselves in those 4 use cases we discussed earlier, they can quickly understand where the data is coming from, which team it's coming from, and also where the data is moving, so they know it's the right data they want to use. And given that DataZone gives that handshake between the producers and the consumers, they're also able to see who are the other teams that are consuming the data. So it gives them the confidence to say, if this team is consuming this data, maybe this is the data I want to use too. So it gives that handshake, and Lineage gives a more graphical and an easier experience to understand the data better. And the OpenLineage, I'm so excited about it because it gives you a lot more flexibility. Like we saw in the demo that Leo showed or what Rob talked about, it helps you build the data lineage to capture lineage from on-premise database. So OpenLineage has this capability of custom assets. So you can create assets to show the nodes in a way that people understand where the data is coming from, even if it's not automated completely. So you can say this data is coming from an Oracle database on-premise, it's moved to cloud, and then this is where it's cataloged, and this is how it's being consumed. So custom assets gives you the flexibility to define lineage for things that are not happening in the end-to-end system, but still the consumers are able to see the end-to-end picture, and they can understand the data better. So with this, I think I'll invite my co-speakers and we can open up for Q&A. Thank you so much for coming here and spending the time with us. And to quickly wrap up, not done yet. Quickly wrap up, I think the biggest announcement of this week was the SageMaker Unified Studio and the whole pillar portfolio that we launched. And I wanted to emphasize the fact that if you're familiar with DataZone, DataZone is powering the governance layer of this new launch, and you will get to see the same features that you see with DataZone as well. So Lineage is built in, and as a user of the next generation SageMaker, you'll get to go to the marketplace, find the data, understand, and also navigate to Lineage and know where the data is coming from. No? All right, thank you everyone. Thank you so much for making it here.
Thank you.